Hello everyone, this is Abdullah from Final International University. In this video I will be covering and providing some information regarding the 11th chapter of Data Communication and Computer Networks. This chapter is covering the topics in voice and data delivery networks. So as an introduction of this chapter, let's see, back in the days, students used to go to either data communications or voice communications, so there were separately two fields, but nowadays the two fields have merged, or in another way we can say anyone who is studying the field of data communication and networks must learn some basic of the telecommunications too. We are going to face some new terms and phrases here into that voice and data delivery networks. So our first part here is telephone lines, trunks and numbers. So we want to understand how the structure is into the data or voice networks. So let's see, it says here the local loop is the telephone line that runs from the telephone company's central office to your home or business. So from this sentence we understand that there is a central office that provides us the lines, the landlines to our homes or businesses. These lines or this network here called the local loop. So by looking at the local loop we understand that there is another loop called long distance loop, or the long distance provider instead of the central office. A central office is a building that houses the telephone company's switching equipment and provides a local dial tone to your telephone. So that's the aim, or that's the duty a central office has to offer. Now, if you place a long distance call, this is the other term, the central office passes your telephone call to another long distance provider. So from a long distance from a central office to another long distance provider. This long distance provider will connect you to another central office into that area, then you will make the call. We will have more information on this further. The country is divided into few hundred local access transport areas, or the LATAs. This local access transport areas is the one who's responsible to handle the local loop requests from the central offices or office to the subscribers, homes or small businesses. So if your call goes from one LATA to another, it is a long distance call, and it's handled by long distance telephone company or long distance provider. Let's have a look at this figure here. This is my first LATA one. So any connections within this LATA is considered as a local loop or a local call. This is another one, applies the same analogy here. So if a connection is requested or made from the first one to another one, so it's considered as a long distance call handled by a long distance telephone company or a long distance provider. In another hand, if your call stays within the LATA, means it's a local call as we mentioned, so it is handled by the local telephone company's central office, as you see in this figure here. Now we have a new term called trunk. A trunk is a communication line or link designed to carry multiple signals. So that's the special about a trunk. Multiple signals simultaneously to provide network access between 2 points. But generally, a trunk is to connect switching centers in a communication system. The signal can carry or can handle any type of communications data. So therefore, it's not an analog signal, it's a digital signal. After that, we are seeing some new terms into this network. The POTS, or the plain old telephone service, is the landline telephone system we know today, which is connecting between a subscriber. And private branch exchange, PBX, is a common internal phone switching system. So it's a phone switching system for medium to large size business. So this is not for a single or for small users, homes and small businesses. It's from medium to large size business. Another thing is the Centrex, Central Office Exchange Service. Is like having the private branch exchange, but this private branch exchange reside at the local telephone company. So it's for the local telephone company, it's not for the subscribers. Yes, so let's have a look at some history in the US before 1984 and after 1984. A lot of important events happened that changed the way the companies used to manage the local and long distance circuits telephone landlines. So in 1984, US government broke up AT&T, which was the biggest, largest company that is handling all the local and long distance telephone circuits. So before then, AT&T owned large majority of all local telephone circuits and all the long distance services. So some other companies, they did not agree with this situation, and they established kind of work between each other against AT&T. And finally, as a result of this complement, a modified final judgment, MFJ, happened. So of 1984, AT&T had to split off local telephone companies from long distance company. So they split this company off, so other companies can take place and be a part of the development and managing the service. So as another result of this modified judgment was the creation of the LATA, which is we mentioned before, the local access and transport area, which divides the country into hundreds of LATAs. Each LATA is handled by company or couple of companies. So a local telephone companies became known as local exchange carriers, and long distance telephone companies become known as inter-exchange carriers. This is as another result of the final modified judgment. So back to the POTS line service. It was designed to transmit the human voice, which has a bandwidth less than 4 kHz. Now, a telephone conversation requires two channels, one for sender, one for receiver, each occupying 4 kHz as a human voice. Now, a 4 kHz analog system signal can only carry about 33.6 K bits per second of information, while another digital signal, which has the same frequency, can carry about 56K bits per second. So with the same frequency, but the type of the signal is changed from analog to signal, we can carry more. So if you want to send information faster, you need a signal with a higher frequency, or you need to merge more advanced modulation techniques. As a result of this situation, 56K modem, which is 56K bits per second, achieves this speed by combining or merging digital signaling with analog signaling, as we mentioned. But actually, this could reach another higher speed, which is 64K, but due to the following reasons, it could not, unfortunately. First reason was the local loop is still analog, so it's an analog signaling, which is again cannot carry that speed. Analog to digital conversion at a local medium introduces noise, white noise, and some errors, jitter and other errors, and combined, this shortcoming drop the speed at best 56K bits per second. But again, this is the best speed, but it doesn't even reach to 56K due to line noise and other factors. So, as technology goes, new equipments are showing up. What is replacing the 56K for in-home internet access? So now we are introducing the digital subscriber line, the DSL. A DSL can provide very high data transfer rates over standard telephone lines. Cable modems. Let's first have a look at the DSL. So because of DSL is highly dependent upon noise level, a subscriber cannot be any more than 5.5 kilometers from the DSL central office. So a subscriber or a user has to be within this range to have or to obtain the optimatic solution of a DSL service. And the DSL service is often connects a user to the internet, can also provide a regular telephone service, the landline service. The DSL provider uses a DSL access multiplexer to split off the individual DSL line into home and businesses. So to have two separate categories of subscribers, homes and businesses. Most are external devices that connect to a personal computer through a common Ethernet card, can provide data transfer speeds between 500K bits per second and 25 megabits per second. So it's quite high speed. DSL and cable modems are great for home users and small commercial users, for small businesses, shops, whatever. So if a channel is used for voice, each byte is one type of PCM encoded voice. If a channel is used for data, each byte contains 7 bits of data and 1 bit of control. So 7 multiplied 8K is 56K bits per second. We don't consider the bit for control. That's for the T1 list line service. And with the end of my presentation today. Thank you so much for listening. Hope you got the idea. Thank you.